Hey guys, welcome to the session. My name is Nate Dye. I'm a software development manager on the AWS WAF team. And I'm both happy and very relieved to be speaking with you today because it means my team successfully launched our service yesterday at 10 a.m. Thanks, guys. Our talk today will cover three main areas. First, you can expect to see, I will, if the internet gods allow me to, show you a live demo of the AWS WAF, walk you through the console, and so you'll get to see exactly how to get started and start making use of the service. It is a 300-level session, so I'm going to skip over some details and assume you guys have some knowledge of what web requests look like, details like web request headers, and an understanding of how IP addressing works. And lastly, I've got a lot to cover. I'm just doing this big upload. So there's a whole lot of content here. But if stuff doesn't make sense, or if you want more information, we've got representatives at the new services booth, and we'll be happy to answer any questions you have. So that'll get us through the deep dive section. I also spent a bit of time talking about web defense strategies that were based not only on the experience that we have inside of Amazon in building up some web defenses, but also things I learned just by talking to customers and understanding what kind of features we needed to build into the AWS WAF. And finally, another thing that I discovered through those customer conversations was I'm really seeing this emerging trend in security where automation is coming more and more to the forefront. It's an integral part of defensive strategies out there, and I'll talk a little bit about some of the things I'm seeing and give you some ideas about how you can build automation with AWS WAF. We have a customer today who's also here, Art, from ConnectWise. Will give you a walkthrough of how they made use of AWS WAF as part of the AWS WAF private beta program. So, as I talk to customers to understand their needs around AWS Web Application Firewalls, I really wanted to understand what kind of problems they were facing and why they wanted an AWS WAF. And what I learned is that, first and foremost, customers install web application firewalls in front of their web servers to have a way to respond to potential threats on the internet. When they learn about application vulnerabilities in their application, like a SQL injection vulnerability, customers need a way to deploy a rule to prevent those requests from taking advantage of that vulnerability. But in practice, this was actually one of the more common use cases, abuse use cases that customers said they use WAFs for. And abuse is slightly different than just straight vulnerability exploit in that it might be just robots that are out there scanning your site, but maybe getting a little bit vigorous with their activities and causing resource utilization. Or maybe it's a little bit more nefarious than that, and that bot is actually trying to take your content, which is publicly available, but it's not something you want to be scraped and posted up on somebody else's website. So customers use web application firewalls to find those situations and block those bad actors. And finally, commonly, there are malicious users out there whose intent is to bring your website down, and at the web layer, DDoS is something that comes up. Now, application layer DDoSes are a bit different than some of the really big, scary events that you hear about on the news. These tend to be not the 100 gig attacks. They're more like the 10 requests per second to maybe up to 10,000 requests per second, so they're not really huge events. And in those cases, customers use WAF to find and filter out those requests based on IP blacklists or header inspection. WAFs work by putting a service layer in between the public internet and your users and your web service infrastructure. They give you rules that let you define who's allowed and who's not, and usually come along with some extra visibility features, graphs, and logs to let you know what those rules are doing and how they're interacting with your web traffic. And there are a lot of solutions available today, both open source and a lot of great solutions on the AWS marketplace that are very good at this, but customers were still asking AWS to provide a solution directly for them, which caused me to ask them why. I really had to understand it. And what customers said was that a lot of the solutions available today, or the traditional solutions, tended to have very high cost of initial setup, either from an actual monetary perspective, just big expensive startup costs, or from a time perspective, the complexity of network configuration or rule configuration, and they wanted an alternative to that that was quick and simple. Something I also heard that was surprising was that many of the solutions offered very comprehensive rule sets, but in practice, customers said, yeah, you know what, those are nice, but I really don't actually use them on a day-to-day basis because they tend to be maintenance heavy. They result in false positives, and I don't have time to keep watching these things. And really, I kind of use a set of mitigations like IP blacklisting and whitelisting on a day-to-day basis, and then occasionally, when those vulnerability events occur, I need to be able to create a signature on block requests based on that. And finally, the really big point that customers said was the existing solutions are really difficult to automate. And for those customers that are running in AWS, that are using a service team and DevOps model and are applying automation to provision their stacks, are having trouble integrating web security into part of all of that automation. And they wanted really good APIs. And the emerging trend is that security operations teams are relying more and more on automation and are looking for better tools to help them with that. So AWS WAF was built to address those three main areas. We give you a customizable rule set that allows you to block or allow requests based on IP addresses, string match conditions, or by checking for valid SQL statements inside of a web request. You can use AWS WAF to monitor security events with new 1-minute CloudWatch metrics and alarms that can tell you when certain activities are happening on your website. And we also provide sampled web requests so you can see the exact details of requests that are matching your rules. AWS WAF launches as a new API endpoint and a new portion in the AWS Management Console that gives you access to configure your rules and monitor activities. And you can associate those rules with your CloudFront distributions. I like to say that AWS WAF gives customers the security features they need, but with a unique approach to security, in that we provide customers with the types of rules they tell us they use most, the proven stuff that people use every day. But to really actually solve the problem customers were asking us to solve, those rules have to be fast and easy to set up. So our goal in building this product was to ensure that a customer could deploy a new rule set, like an IP blacklist, in less than 5 minutes. And that kind of speed to deployment is really useful when you discover that you have a critical security bug in your web application and you need to mitigate that flaw in a hurry. We built a lot of flexibility and customizability into the AWS WAF. Right out of the box, you have completely customizable rule sets. You're not restricted just to pre-configured rules. You also get to reuse your rule configuration however you want to. So you can define one rule set and apply it to many CloudFront distributions, or define a unique rule set for each of your individual CloudFront distributions. And I think that's going to be very interesting, especially in larger companies. You know, in some cases where you might be following that service team model, you want to delegate security policies out to the development and engineering teams that are building those services. You can certainly do that. In other cases, you might have centralized security teams, when you want to standardize on policies that apply across all of your services. You can do that too. You can also use a hybrid model, and you can delegate out portions of your rule set to one service team for them to manage it, while retaining some centralized configuration management that's standardized across all of your points of presence. The core features themselves are also usable as building block components. So if you like the visibility features, but you don't really want to do the blocking, you can do that too. One of our internal Amazon customers saw the rule set and saw what they could do with sampled requests and the new metrics, and they said, this is really cool. I'm going to use this just to troubleshoot user activity on my website, but I'm probably not going to do any of the blocking stuff. Finally, we think that this new service has a way to transform the way web security works by making it easy to integrate with the whole software development lifecycle. So the barrier to entry has been lowered. You can build your WAF into your dev and test environments and include it in all of your integration testing all along the way as you go into production. All right, now that you've got a bit of background about why we decided to build WAF, I'll show you how the system works. So to set up AWS WAF, you first need to create something we call a WebACL. That was a much debated name within the team. There was a big consortium of engineers that were voting for a waffle. They thought that would make a lot of sense and would be really great, but I played the sad manager and said, no, I don't think we can do that. I compromised on WebACL, which I call wackles, and it's kind of silly, but not quite a waffle. Anyway, you create your WebACL, you set it to your default policy. In most cases, customers will by default allow requests. Then you need to add rules that specify under what conditions you want to block requests by adding specific conditions, like checking for a specific IP address. And finally, you take that WebACL and rule set and you associate it with your CloudFront distributions. And now, let's see. Wait a minute. There it is. Okay, so here's the AWS WAF console. To create a new WebACL, let me jump in here. Okay. Click next. So that's the name of our high-level WebACL. We also need the metric that will be the default metric. That bigger? Yes. Oh, that actually helps me a lot too. I have to look at it down here. All right, so now the next step in the wizard, you can create your conditions. You see the 3 types of conditions we support: IP match conditions, string match conditions, or SQL injection match conditions. You can modify them here. It's pretty straightforward. So if we have a new IP blacklist, and we can add a new range, and let's say we're going to block all the internal addresses. There we go. Okay. And in the next phase, this is where we bring all of the rules together. So for the purposes of this demo, I'll just use some of the pre-configured rules we have. Let's say we'll grab this blacklist rule. Maybe we've got some known bad attack signatures and we're using some SQL injection detection here. And we'll configure these rules to block if we get any match requests, but by default, we'll allow the request to go through. All right, that's it. Now from here, you would pop into the CloudFront console and associate your distribution with that new web access control list. And the end result is okay. So I got a little snippet of badness here. This is just a curl command that'll make a web request, and this is a little snippet of some SQL injection attempt coming in over the query string parameter, and it's going against my CloudFront distribution. And I run it, and then I get denied no access. I'm going to do a few of these because I'll show you some visibility features. We'll see these in sampled requests later. All right. So on the match conditions, I mentioned we have IP, string-based, and SQL injection. On the IP match sets, we support defining network ranges on these CIDR boundaries. So you can do /8 through /32. A /8 example there would match any source IP coming from 192. And then at the last example, a /32 is a fully qualified IP address that would exactly match one specific IP address. Today, we support 1,000 CIDR entries per IP set. And in total, for one given WebACL, you could define 10,000 CIDRs. That's a lot of IPs to block, if you like, or whitelist. I'll note that this version with CloudFront is validating the connecting IP address that CloudFront sees. So if attackers are injecting an X44 header, In this case, we ignore that. We're just going to use the connecting IP address. So string and byte match conditions are something I think, these are the heart and soul of a WAF, really. These are what most of the rules are defined in. You will use string match sets to define signatures looking for vulnerability exploits. These, you can use these to do things like filter for cross-site scripting events, or even sometimes bad bots may have some signature in their user agent string that you can filter on. And just as a simple example, I'll walk you through a common use case for customers that want to protect their content from hot linking. They frequently use refer checking for that, and that's something that you can do with a string match condition. And the way that works is you've got good users out there who are using regular browsers, all of the usual suspects, and those browsers follow the RFC, which specifies how this refer header should behave. I missed that. The tech editor corrected the spelling and made it spelled correctly. It's not actually spelled with 2 R's. Okay, so good browser sends a refer header, example.com. Now, under normal circumstances, when you have a website and the browser's requesting objects, the refer header will match that same website. If somebody's hot linking to your content, that refer header is going to look like something else. It'll be a different website. So you can create a whitelist based on that and restrict access to only people that are accessing your objects from your website. On the right side, or left side, the blue box, that's the web request, and you'll see the refer header there, or example.com. You create a string match condition that indexes into the refer header and uses a contain search string to look for example.com, and if you see it, allow it, and the request will go through. Something to be aware of when you're building these rules is that the clients do control every aspect of that header. So in a well-behaved browser, you can predict and expect that behavior to be good, but if you're dealing with a scraper bot or somebody's automation, they have complete control over the strings that they're setting. And they will use techniques to try to evade your WAF rules. A lot of WAFs are case sensitive, and actually ours as well. Our strings are by default case sensitive in their matches. And attackers know this, and they can do things like varying the case. So in this case, the user agent string's been changed to bad bot, but the casing has been scrambled. Our string match sets provide something we call transforms, which help with preventing those evasions. So in this example, you'd set a to lower directive. We're going to lowercase that string before we search for the bad bot signature. Out of the gate, we support 5 different match types. The contains is the one that will probably be most frequently used because it's pretty straightforward and easy. But we gave you more than that, and we went beyond that. If you're familiar, there's an open source organization called OWASP, which publishes a list of security WAF rules called the core rule set. It's used by services like Mod Security and a number of popular web application firewalls. And our engineering team combed through all of those rule sets, and we pulled out the most frequently used search directives. And this is the list that we came up with. So our goal here was to ensure that that customers could use the AWS WAF to import any signature they find in that core rule set. We're not limited to just strings. You can search for any bytes. That's useful. Sometimes script or automation do funky things and inject non-printable characters and make a great signature to filter on. Or there might be some malicious bit of binary that somebody's trying to shove through your website. To check for binary data, just take your snippet byte stream, base64, encode it, and then you can put it into the API or upload it into the management console and create a signature on it. String match conditions, you can do 10 string match conditions per string match set that are all ORed together. And within one web ACL, you get a total of 1,000 string match conditions you can configure. Our SQL injection directive is one of the 2 most popularly requested built-in mitigations. The basic premise here is that SQL injection attacks, the attackers are trying to shove in some SQL query that would get passed through your web server infrastructure to your database to extract data or do other various nefarious things. And our SQL injection system works not based on just simple keyword searches. We're not just looking for set or update or select. We're actually checking for syntactically valid SQL. So we think that'll help reduce some of the false positives. And a quick walk through the order of operations here. So in our example, we configured a SQL injection match set that does a URL decode transform. So the first thing we'll do is strip out all the URL encoding, and we end up with this string. And then in the next phase, we're going to check for syntactically valid SQL. And in this example, we get a match. So we're going to block it if you tell us to. All of these conditions are completely customizable. You can combine them, combine an IP set condition with a string match condition to further narrow in your rule set. And we support more than just blocking or allowing. You can also just put these things out in count mode and get some of the monitoring features. So as a quick example of combining conditions together, if you are hosting a website that might have an admin, a set of admin pages that are accessible over the internet, but are not something you want everybody to be able to try and brute force with a login attempt, you could create a combination rule by inspecting the URI string and limiting the IP address, and it would look something like this. So within a rule, you'd have your IP set, and in my example, saying only these IPs from my Seattle office, this known set of trusted IP addresses, is allowed, and I want to apply this rule to just the admin page, so just /admin/login. The order of rules matters. We start at the top and move through and check a request against each rule until we either hit allow or a block condition. So if you want to let your pen testers bypass all of your rules and get straight at your infrastructure, you would add a whitelist right at the top of the stack that matches on some parameter, like IP addresses of the pen testers, and set an allow directive. Now, if that request matches that first rule, we'll skip out of all the other rule processing and we'll allow it through. If they don't match, they go through the whole root chain until they get to the default rule. You can reuse rules. I mentioned the rule reusability. This is an example of what a policy would look like where you have two service teams that are controlling their individual rules, but you want to take advantage of having one common IP blacklist that's shared across all of your infrastructure. So in this case, that shared IP blacklist is referenced by WebACL 1 and WebACL 2, and those in turn are assigned to CloudFront distributions. Now, if you need to update your blacklist, you've only got one place you need to change. It's one API call. When creating and managing WebACLs, we felt it was super important that customers have fast feedback. For propagating rule changes out, if there's an incident that you need to respond to, you want that to happen very quickly. And on the other side, if you make a mistake and you start blocking traffic you don't expect, you need to be able to undo that just as fast. So our change propagation times go into sync worldwide in about a minute. We used the same change propagation technology that Route 53 uses, which has proven pretty reliable. But getting configuration out isn't enough. You also need to see what's happening. So we offer you 1-minute metrics through CloudFront. And we think that that whole cycle time between putting a rule out, seeing its effect, and then adapting as necessary can happen in less than 5 minutes in each iteration. That's a quick sample of some requests and sampled requests, and I actually have another quick demo here. Again, if I'm lucky, I generated some of those requests, and if I go into my main site here, all right, so earlier in the presentation, I generated a number of requests. You can see my SQL injection attempts. If we expand this flyout, you get to see all of the details of the web request. Oop, a little bit too big. So you might look, well, this is interesting. So here's a x-custom-header hello that's being passed in the front door. That would be a really super easy thing to filter on if this particular request was causing you trouble. We are an AWS service, so you get your pick of automation tool sets via the AWS SDK. And for those of you that are planning to build automation, I've got a couple of usage notes on our API. So the first part of our API, when you're interacting with it, anytime you want to make a mutating call or create a new entity, we have you get a change token first. So you'll need to make this get change token call. This change token is a way to prevent any kind of conflicts that result of concurrent changes coming in the front door, and is also the thing that you will use to find out the state of your change as it propagates to all the CloudFront Edge locations. Here's an example of a create call. I'm passing the change token in. Once that call succeeds, I can query for get change token status. When you initially get a change token, we put it in a provision state. When you created or updated an object using that change token, we flip it into a pending state. And that means that the system's received it, we're propagating it out to all edge locations. And then the final state is in sync when that change is in effect worldwide. The style of our updates uses insert delete convention instead of any kind of document overwrite convention. We think this is going to be useful if you're creating any kind of fail to band automation where you might be doing log parsing off to the side, identifying IPs, and you want to just add those IPs to your rule. With the insert delete operations, you can do that without having to remember all of the IPs that are supposed to be in your rule set. You just need to push the new one. And an example here of GetSampledRequests, which are available through the API as well. Each sampled request shows you the action the WAF took, and this is coming through the AWS CLI, so it's in a JSON parsable format. We also give you the origin country and the connecting client IP address there. And then you can see some examples of the header information. And in this case, we've got a user agent that says it's using curl version 7.3, which is probably pretty suspicious. That's a command line tool and not a regular browser. With AWS WAF, you pay for what you use. There's no upfront minimums. If you want, you can use it for just an hour, or you can leave it always on. It costs $5 for each WebACL and then $1 for every rule inside of a WebACL. But you can reuse those WebACLs across as many CloudFront distributions as you want with no additional charge. And this pricing really follows our visibility costs, that for each rule, we're giving you a new CloudWatch metric on a minutely basis, and we're providing you with all of the sampled request streaming. And then on the evaluation side, that condition evaluation side and the cost of doing that inspection on the CloudFront Edge locations is covered by the 60 cents per million requests fee. So based on a lot of solutions that are out there, that pricing model actually really lowers the barrier to entry, and I think makes this a solution that can actually even be integrated into your dev and test environments. And comparing to many of the other solutions, we found that customers are actually going to save a lot on their WAF bills. And there's a couple of quick pricing examples. So in a test environment where you might just have one rule, maybe you're just using it for visibility, you would pay $6 a month. And for a small site that's generating 58 million requests per month with 6 rules would pay $46. With higher request volume of 260 million requests per month, you'd pay $167. All right, now that we've got an overview of the WAF, let's put it into action. If you've experienced rule configuration before, really there's kind of two main camps or two main styles of policy making when it comes to web application firewalls. The negative security model says, I'm going to allow everything by default, but I know of some bad things that I want to block. So that's the negative aspect, block these specific things. And this is, for web application firewalls, the most typical implementation, because a lot of customers are running WAFs with public websites. And some examples of specific rules you might block for are, you know that there's a network range out there that's just known for generating malware and bad stuff. I'm going to block that. Or, you know, the next shell shock might come out, and you know that that's bad and not valid. You can block that. On the other side is a positive security model, most frequently used for non-public websites where you want to lock down and restrict maybe your QA or test environment to just a set of known good requesters. Also could apply potentially to sites that might have authentication or authorization. This could be an extra layer on top of that that could filter requests out at the edge if you have some token or key you can use as a way to build whitelist policies in the AWS WAF. And then another big trend is static versus reactive policies. So I think most people tend to think of WAF rules as kind of like firewall rules, and they would like to have a way where you can just have a set of rules that really you know are good. They won't really generate any false positives by blocking legitimate requests, and they won't. But I think in customer conversations, what I found was that static policies are actually really tricky to get right. Like, the more rules you add, the more potential you're adding for those false positives. And a really common theme is most customers are tending to actually rely a lot more on reactive policies and using monitoring techniques. They might pre-configure some rules of known bad signatures in a non-blocking mode and use that as a signal. And it looks a lot like this in the AWS WAF world. So you would use that count mode action instead of allowing or blocking a request. You can configure alerts on CloudWatch metrics and get more details about those requests using sample requests, and in turn add those things to blacklists. So this could be human-driven, or later we'll talk about some examples where you can build automation to take care of that for you. So putting it all together, this rule configuration is something I think will be fairly typical or representative of what we'll see. At the top of the list, we'd have whitelisted IPs pre-configured and ready to go. This might be empty, but available and at the ready in case you do have a false positive event. You need to quickly whitelist the customer. Excuse me. You could use the whitelisted IPs to do that. And on the other side is blacklisted IPs. If you having a blacklisted IPs rule sitting there at the ready, even if you don't have any explicitly blacklisted IPs, gives you a really fast place to go and add that IP address and block it from getting to your website when you know bad things are happening. And then the third layer, I have listed some known bad attack signatures. This is where you might have your SQL injection or some other known vulnerabilities, cross-site scripting signatures to block. And then 4 and 5 are just general count mode. Like, customers will often have just some additional rule there for only the purposes of monitoring. So with that, I'm going to bring up our customer speaker, Art, who's from ConnectWise, and he'll walk you through an example that they're using in their site to protect some of their service APIs using AWS WAF. Thanks.
So just a real quick high level about what we are so you guys get a better idea is we're a business automation management software geared towards IT companies. So some problems we have is we have a lot of people that do write integrations and API calls into our software. And that is the use case that we wanted to show and explain to you guys, and a little different on how you can see the context of how WAF is used. So here again is a quick example how we put our users in front of our CloudFront distribution. Again, these are just vendors writing integrations into our application, going to a load balancer. And what we do is how we handle these requests at this time is we have to auto-scale our EC2 instances to determine if the requests are good or bad. So again, this brings workload to your IT team. This brings pricing increases and decreases based on the level of context that's coming in at this time. So what we decided to do is we got with Nate and we put the WAF appliance in front of our dev environment right in front of CloudFront to help us discern what is a good or bad request. Not necessarily malicious, but what we are discerning as good or bad as a request. As again, you can see here, we don't have to worry too much about your EC2 instances scaling as much as WAF is doing most of the heavy lifting before it even enters our CloudFront distribution. So here's a perfect example of what we're trying to examine. For our first use case, we're using a URI context, and we're looking for a specific version of our application. So here you could see a proprietary piece of software that we wrote just to test our actual API calls into our application. This is what you would expect as a successful API call to our specific version of our application, 2015_3. So what we come and do is we created a rule. We're looking for our match string context of the version 2015_3. And here you can see how we had to, as Nate has described, do it via the APIs. There was no console when we gave this a shot. So this is exactly once we apply that rule, you can see right away here, as soon as it hits our CloudFront distribution, we instantly get a 403 forbidden error looking at that exact context string of version 2015_3. So, another use case that we also try to do is we have customers that we actually assign a cookie. So when you become a vendor or an integrator with us, we give you an ID. So in this specific use case, what we are looking for is the use case of our CWQA man_P token, just a random token that we can give to any integrator. Again, this is an example header coming into our API configuration, and once again, we're creating a match string condition on the context of contains. We're looking for that exact cookie. Again, not really the best way to rule out what customers were, but for this match case, we were just trying to show examples quickly of how we can block or allow specific users. Whether they're no longer an integrator, whether they became a competitor, any situation whatsoever, we could block very quickly. Again, as soon as they write to our API integration, they instantly receive a block request. And the important part to note at this point is that it is blocked here at CloudFront. So we're no longer reaching our EC2 instances. We're no longer paying for the CloudFront traffic. We're no longer paying for the EC2 autoscaling on such a significant amount, especially based on volume. So real quick, the savings that we brought to this was instantly you decrease the number of machines you need to prove this logic. We're saving already 20% just in our development environment alone, just by preventing this traffic from hitting our network. So again, use cases, not so SQL injection, not what you would expect to block malicious traffic, but a different takeaway on how you would block or allow specific requests for customers or integrators or vendors. Nate?
All right. All right, I'm back. So we talked a lot about some of the static policy configuration, but I mentioned at the beginning that in talking to customers, I got to learn about a number of use cases where automation is becoming a bit of an emerging trend when it comes to web security. And even inside of Amazon, there's a really common pattern that I've seen over and over and over again, and it looks a lot like this. So the basic gist is you've got your application servers, you've got your web servers that are emitting log data that tells you about everything that's going on and even gives you some details about the requests that are being made. That data is super rich in knowing what good behavior looks like and can give you a lot of clues about what bad behavior looks like. Just as a customer example, another one of our private beta customers is Mapbox. They serve mapping tile data. So think about the maps like in the Foursquare application when you actually want to see streets. They're serving up all that data as a platform. Those mapping tiles are kind of the big important content that they're generating. It's precious to them, but it does need to be available over the internet. And from time to time, there are people out there, robots, that really like those mapping tiles and they want to take them for themselves and they just build harvesters that start scraping it. Mapbox noticed that it's really, really obvious when a non-human is doing that because a robot, like humans usually are looking at something very specific and useful like a street. robots are just scanning through, and even when they get to something like miles and miles and miles of the same blue ocean tile, they seem to be perfectly happy to keep downloading them. And it shows up very clearly in the access logs, and Mapbox was able to create a signature to look for that, identify the IP address of that bad attacker, and then turn that around and turn it into something to block and prevent that content scraping. And internally, inside of Amazon, this happens over and over and over again. I know the retail site does a lot using these techniques and a similar kind of blacklisting mechanism. And then even on the edge services side, this isn't a web application use case, but for the Route 53 service, we do look at the log data and mine that for information to look at good behaviors and bad behaviors, and we use that to feed back into some of our own firewalling and blocking mechanisms at the edge. So this use case was something we had very clearly in mind when we built those APIs and automation, and I'm very interested to see what customers do with it. And to get you thinking about it more, we actually have a demo, a walkthrough to show you. It's being demoed in detail in the SDG 205, Securing Content Using Amazon CloudFront, or you can stop by the new services booth and we can show you. But the basic gist is this. We are relying on a behavior of robot activity that robots that are good are supposed to go to your website, request robot.txt, and receive instructions from your website about what they are and aren't supposed to do. Well, we use that to tell them, don't go to this specific URL on our website. And then we pair that with a new rule that looks for any robots that are hitting that part of our website. And we know that if they're there and we've told them not to, they're not behaving properly, and we can add them to our blacklist. Because this kind of automation and behavioral analysis is a bit of an emerging trend, I had trouble finding a lot of really good external resources. I did find one that I would consider to be very good, and I've included it here. There's an engineer named Aaron Bedra who's currently working at Groupon, and he published this slide share that talks a lot about some of the techniques that he's developed around behavioral-based system, and had a lot of really good examples. Like, for instance, one great example of a web use case that you know is an indicator of bad behavior is a login page. So if you have a login page, you expect to get post data credentials coming through, but normal users will probably have gone to some other page before they got there. And certainly, they would have made a GET request to the login page in order to enter in their details. So good behavior looks like a get, and then the post. But bots who are trying to brute force a login attempt may never have had that preceding GET request. They're just going to post. That shows up really clearly in the logs. And there's even an open source tool that Aaron published called RepSheet, which is based all around that idea to construct behavioral rules that are doing log analysis and feeding that back into blacklists. We had 3 AWS partners participate in the WAF solution for exactly the purpose of building better reactive automation and finding ways to integrate that with the AWS WAF technology. All 3 of these vendors offer or have spent many years building great automation to detect bad behavior, look at signatures, and even develop automatically updating reputation lists. And as I said, are exploring ways that they can make those things available through to AWS customers via the AWS WAF APIs. AlertLogic in particular, all 3 vendors are here at the booth and have some examples to talk through, and they're looking for customers to provide them feedback. And AlertLogic actually has a working proof of concept that uses one of their inline WAF appliances in the AWS cloud that is in line with all of your traffic. They're running their analysis on that traffic, and when they identify the bad behavior, they block it initially here, but then also trigger an update through the AWS WAF API to an IP list that customers configure so that blocking can occur at the edge. And the useful thing here, the combination of these 2 things gets you a best of both worlds. You get right at that out-of-the-box automation from the AWS partner solution, and you get the benefit of that in front of CloudFront, in front of any cache content that you might want to protect. And then as a final example, what I'll leave you with is good automation, or automation that improves security, doesn't have to be super sophisticated. It doesn't have to be deep behavioral analysis stuff. There is a lot of simple automation that can do a lot to improve your security stance. And this is one example that's just stitching together some of the AWS tools that are available to you today. So in this case, you start with that CloudWatch metric, you build an alarm off of it, and you can subscribe yourself directly to an SNS topic and get an email directly. Or you can subscribe a Lambda function to that SNS topic, make a call out to the AWS API, grab some additional information, and then push that information right back onto an SNS queue to get yourself an email. Setting this up, really, it takes less than 30 minutes to do it. And I can actually give you a quick example of setting up a CloudWatch alarm using some of these new metrics. Okay, I'm going to browse to my CloudWatch metrics. I'll pull up the new WAF metrics. So as I mentioned, we give you all the blocked, allowed, or counted details at the rule level and even at the web ACL level. So let me pull up one of my guys here. So in this case, I've got my known bad attack signatures rule that's associated with my main site. Actually, let me see who's got actual blocking. That's a little bit better. Okay, with that rule selected, we can create an alarm right here. So in this case, I want to alarm if I ever see any more than 10 requests in a 5-minute period, matching and blocking on this rule. We have a couple choices of where we can send that notification to. If we're not interested in the automation and we want to just do a direct notification, then we can use an SNS topic that just goes off to an email list. Or we can publish to an SNS topic and subscribe a custom automation to that or a Lambda script. All right. Well, that's what I got. Thank you very much for coming to the talk today.